Hi guys! Today we're going to look at coroutines in Unity. We'll explain what they are and how to use them. Okay, we'll start by creating a new 3D URP project in Unity Hub. Once the project loads, we'll click the plus button in the hierarchy and select 3D object, cube. Then we'll click on the Add Component button and add a new script. We'll call this Coroutine Test. Then we'll double-click the script to open it in the editor. We've got the usual default script with the start and update methods. Anything we put in the update method will be executed in a single frame. Coroutines give us a different option by allowing us to spread the execution of a process across multiple frames. Let's look at a simple example to show how this works. We'll create a new method called example coroutine. For a coroutine to work, we can't use the void return type. Instead, we need to use IEnumerator. IEnumerator allows iteration over a collection. In this case, it'll be a collection of steps that make up the coroutine. What Unity will do in the current frame is execute all the code in the coroutine until it hits a yield statement. So for example, let's add 2 debug lines that output the frame count. Then we'll add the line yield return null. After this, we'll add in another 2 debug lines. When this coroutine runs, Unity will execute the first 2 debug lines in the first frame. A yield statement will tell Unity that the coroutine is done for this frame. Yield return null tells Unity to stop for this frame and continue again in the next frame. So the next 2 debug lines will execute in the second frame. Before this coroutine does anything, we need to start it. We'll do this in the start method using the start coroutine method. We'll use our example coroutine method as a parameter. Okay, let's save this and switch to Unity to give it a try. If we look at the console, we can see 2 debug lines saying frame 1 and 2 saying frame 2. Now let's stop the game and switch back to the script to make it a bit more interesting. We're going to replace the content of the coroutine with a sequence that increases the size of the cube, waits for a few seconds, and then shrinks it back down again. We'll start by deleting what we have at the moment. We're going to use lerp to change the scale of the cube. For this, we'll need a float variable to keep track of how much time has elapsed. We'll initialize this to 0. We'll add another float variable for the transition percentage. This also needs initializing to 0. Then we'll add a variable to store the start value for the scale. We'll set this to the current local scale. Next, we want to loop until the transition is complete. To do this, we'll create a while loop that keeps going until the transition percentage is 1. Inside the loop, we'll increase the elapsed time by time.delta time. Then we'll calculate the transition percentage by dividing the elapsed time by the total time we want the transition to take. We'll set this to 2 seconds. We can now use these values to change the scale of the cube. We'll use vector3 lerp. We'll pass in the start scale as the starting value. For the desired scale, we'll use a vector with a size of 3 on all axes. Then we'll pass in the transition percentage. At the moment, we don't have any yield statements. This would result in the whole loop being executed in one frame. Let's add in a yield return null line at the end of the while loop to fix this. Now it will only do one iteration of the loop each frame. It's worth noting at this point that coroutines are not multi-threaded, so you don't want to do too much in a coroutine before yielding, otherwise you'll block the main game thread. Okay, let's save the script and test out what we have so far. We can see the cube now grows over a period of time. Let's stop this and switch back to the script to finish off our coroutine. We want to wait for a period of time before we shrink the cube back down. Fortunately, Unity has a really easy way of doing this. After the loop, instead of doing yield return null, we'll do yield return new wait for seconds. We'll pass in 2 seconds. Rather than waiting until the next frame, Unity will now wait 2 seconds before continuing with the coroutine. There are several other useful yield instructions that Unity provides. For example, there's wait until, which allows you to specify a condition to wait for. Another really useful one is async operation. This is returned from things like scene loads and allows you to wait until long-running operations are complete. A common use case for this is to fade out the current scene, then wait for the next scene to load by doing a yield return on the async operation, and then fade back in the new scene. OK, after we've waited for 2 seconds, we want to scale the cube back down again. We could just copy and paste the code and alter it a little, but this is a good opportunity to show how coroutines can be split into multiple methods. We'll create a new method called scale coroutine, remembering to return enumerator. We'll add parameters for the start and end scale values. Then we'll cut and paste the scaling code from our original method. We just need to change the values used in the lerp to use the parameters of the method. OK, now in the original method we can do yield return and call the new method. We'll pass in the current scale for the start and desired scale for the end. After the wait, we'll make the same call, but pass in a scale of 1 for the end value. So now the coroutine will call off to this sub coroutine to scale up, and then call it again to scale down. Let's save this and switch back to Unity to try it out. The cube increases in size as before. Then it waits a couple of seconds before shrinking back down. OK, let's stop the game and switch back to the script to make a few more changes. At the moment, the cube just increases and decreases in size once. There's nothing stopping us doing this a number of times, or even having it repeat forever. Let's surround the code in the coroutine with a while loop that never exits. Let's save this and switch back to Unity to give it a try. Now the cube keeps increasing and decreasing in size forever. Let's stop this and switch back to the script to see how we can stop a running coroutine. In the update method, we'll check if the spacebar has been pressed. If it has, we want to stop the coroutine. We could do this by calling stop all coroutines. This stops all coroutines running on this game object. As we only have one coroutine, this would work fine. If we had more than one, we may want to be able to specify the exact one. To do this, we can add a field to store a reference to the coroutine. Then we can set this to the value that's returned from the start coroutine method. In the update method, we can now call stop coroutine and pass in the coroutine we want to stop. Let's save the script and switch back to Unity to try this out. Now, when we press the spacebar, the coroutine stops. Let's stop the game and switch back to the script to look at one final thing. One not very well publicised feature of coroutines is that the start method itself can be a coroutine. We'll change the return type to enumerator. Then we can move all the code from our coroutine directly into the start method. We'll then delete this separate method entirely. Now the start method will run as a coroutine. By doing this, we've lost the ability to store the reference to the coroutine though. We'll delete the field. Then, to stop the coroutine, we can supply the name of the method instead. Let's save this and switch to Unity to try it out. The cube grows and shrinks the same as before, and we can still stop the coroutine by pressing the spacebar. Okay, that covers everything for this video. Hope you found it useful. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Please leave any questions or feedback in the comments, and subscribe and click the bell icon so you don't miss the next one. Thanks guys!